Hi everyone, welcome back. In this video we're going to take a look at the law of sines for precalculus. So chapter 8, section 2. The law of sines is a useful tool that we can use when we're trying to solve for sides or angles in a triangle, and especially a triangle that's not a right triangle. So we've learned in geometry about SOHCAHTOA, sine, cosine, tangent in right triangles, and how we can use trigonometric ratios or ratios of side lengths to find sine, cosine, and tangent of angles in right triangles. We run into issues though where we have triangles that are not right. So here in this triangle, you can see we have angle measurements of 60, 40, and the other angle is 80 degrees. So we don't have a right angle in this triangle, so we can't use SOHCAHTOA or trig ratios from sine, cosine, and tangent to help solve for the other sides. Here we need to use another tool called the law of sines. One note is that any triangle that's not a right triangle we just call an oblique triangle. So you might see this word oblique. It just means there's not a right angle inside of the triangle. Okay, I want to start off by taking a look at a few things that our book says. So sometimes we'll be asked to solve an oblique triangle. All that means is that we are finding the other side lengths and the other angles in the triangle. And sometimes we're given pieces or certain information about the triangle, and then we'll be asked to solve for the other pieces of the triangle. And here we have a list of all of the different cases or situations we'll run into. So sometimes we'll be given an angle, a side, and an angle. Sometimes we'll be given a side and two angles. Sometimes we'll be given two sides and an angle. And the order that this is in is kind of like going around the triangle. We have a side, and then another angle after that. Sometimes we'll be given a side, an angle, and a side, and then three side lengths. And down here we have examples of all of these different situations where we're given some information. For example, over here we have an angle, a side, and an angle in that order. Two things to note. So first, these two cases on the right are not going to be able to be solved using law of sines. So these cases we'll get to in our next section, law of cosines. One other note is that you might notice that angle, angle, angle is not included here. And the reason why is because if we know the three angles of a triangle, the side lengths can be any length. So there isn't one fixed triangle that matches those three given angles only. So you could have a smaller triangle with those three angles. You could have a larger triangle with those three angles. So angle, angle, angle isn't a situation that will be given. The three situations on the left, though, we can solve, and we can use the law of sines to help us solve these. Okay. So next up, I want to take a look at the law of sines. So yeah, one more note is that when we're given a triangle or working with triangles, we'll usually see them in this form, where we have side lengths A, B, and C. And then the opposite angles are going to be the Greek letters, some of the Greek letters associated with these. So the angle opposite of side A is alpha. The angle opposite of side B is beta, alpha, beta, and then the angle opposite of side C is what we call gamma. Okay, so that's some of the terminology that you'll see used. Gamma, okay. All right, cool. Next up, we'll take a look at the law of sines. Okay, so here I've redrawn that kind of like generic triangle with the three sides, A, B, and C, and then angles alpha, beta, and gamma. And then the law of sines tells us that we can take the sine of an angle, and if we divide it by the corresponding side opposite of that angle, so sine of alpha divided by A, that value is equal to the sine of either of the other two angles, for example, beta, divided by its opposite side, so beta divided by side B. So those two values are also equal to, we could do the same thing with the last angle inside, sine of gamma divided by C. So this right here is the law of sine. Okay, and there is a proof in the book that goes through why this is true. I don't want to have this video take a long time, so we're not going to go through the proof. I just want to introduce this law and then show how we can use it. So we can use this law of sines, and we can set up any of these two to be equal to each other, and then solve the equation to find the remaining angles or the remaining sides. At this point, we'll pretty much just be solving for side lengths. So we'll usually be given the angles that we need and then solve for the side lengths. So this is a way that we could solve those other situations that were listed, that we looked at previously. We scroll up, angle, angle, side, angle, or side, angle. Let's take a look at our first example. So up here, we had a triangle that's not a right triangle, it's oblique, and we can't solve it using just trigonometric ratios. We can, however, use the law of sines to help us out. We could start off by taking the sine of 60 degrees, dividing it by its opposite side, b, and that's equal to, so some other information we're given, sine of 40 degrees divided by 4. So here we've set up an equation. The sine of an angle divided by its opposite side is equal to the sine of any other angle divided by its opposite side. Okay, when we take sine of 60, sine of 40, we'll just get some numbers. We're trying to solve, in this case, for b. So what we can do is multiply both sides by b. Sine of 60, b times sine 40 divided by 4. And then divide both sides by this value over here. So b is going to be equal to sine of 60 divided by sine of 40 divided by 4. Okay, and then I can just use my calculator to solve this. Okay, so here we see that b is equal to 5.389 about. So right around 5.389 for b. Okay, and if we wanted to find our last side length, c. So first we know that gamma, as we mentioned earlier, is going to be 80 degrees, and that's because we know that the angles add up to 180 degrees. So 180 equals 60 plus 40 plus gamma. So in this case, 80 degrees. Then finally, we can use law of sines. Sine of 80 degrees divided by c equals, and then we can use either of the other two ratios we found. I'm going to use the ones that were given to us at the beginning, sine of 40 degrees divided by 4. And again, we can multiply both sides by c, and then divide both sides by sine 40 degrees divided by 4. Okay, so here we get c is equal to about 6.128. 6.128 for this side. Okay, so in this video, we introduced the law of sines, and we showed how we could use it to solve for oblique triangles. So sometimes we'll be given a triangle that's not right and still asked to solve given some pieces of the triangle.